Hey guys, a very good day to you all. In this video, we will understand what is solubility and we will also understand the factors affecting solubility. Now, to understand solubility, you must first understand what is a saturated solution. So to understand the saturated solution, let us consider a glass of water. Now, what you do is that you add, let's say, 10 moles of salt in it. Okay, so you add 10 moles of salt and you stir the solution and you observe that the salt gets quickly dissolved in water. Now guys, can I say here the salt gets dissolved in water, therefore the salt is our solute and water is our solvent. Now what you do is that you add another 10 moles of salt in this, and when you add another 10 moles of salt and when you stir the solution, you observe that now also the salt gets quickly dissolved in water. So guys, finally can I say that initially the solute gets dissolved quickly, okay, but now when you add another 10 moles of salt, you observe that now it takes long time for you to stir the solution in order for the salt to get dissolved. Now guys, can I say that now the salt is taking more time to get dissolved in a solution. Okay, now what you do is that you add another 10 moles of salt in it, and now you observe that it takes more longer time for the salt to get dissolved in water. So guys, now can I say that the rate of dissolution has now decreased? What is dissolution? Dissolution is a process in which solute gets dissolved in solvent. As simple as that. The process in which solute gets dissolved in solvent is called as dissolution. So guys, now can I say, since the salt is taking a long time to dissolve in solute, that is our water, so therefore the rate of dissolution has now decreased. Now guys, what you do is that now you add another 10 moles of salt in it, and now you stir the solution, and even after stirring the solution for a long time, you observe that still there is 10 moles of salt which is undissolved. So can I say that after you stir the solution, now you have 10 moles of salt that is undissolved. And this type of solution which cannot dissolve more amount of salt, or a solution which cannot dissolve more amount of solute, is called as a saturated solution. So a saturated solution, after a specific limit, it cannot dissolve more amount of solute. So I hope guys that you have understood what is a saturated solution. A saturated solution cannot dissolve more amount of solute in it. Now, you will obviously be wondering that why is it happening so? Okay, so the reason for this is because there is a dynamic equilibrium that is being established. Now, what is this dynamic equilibrium? Let's understand that. Okay, we all know that a solute gets dissolved in solvent and we get a solution. And in our example, the solute is the salt and the solvent is nothing but water. And we also know that the process in which the solute dissolves with solvent is called as dissolution. And after the dissolution process, we get the solution. But here you need to observe one thing. Yes, we get solution with the help of solute and solvent. So when solute and solvent dissolve, we do get solution. But even the solution gets turned back into respective solute and solvent, and that process is called as crystallization. So as you can observe over here, there is a dissolution which is being taking place, and also there is a crystallization which is taking place in reverse direction. And in crystallization you get the solute and solvent back. Okay, so guys, can I say in our example, the salt gets dissolved in water and we get the salted solution, but at the same time this salted solution also gets turned back into salt and water. So what happens at saturated point is that if you add 10 moles of salt, that 10 moles of salt will get dissolved in water and will give us solution, but the solution will also give us back 10 moles of salt. So if you add 20 moles of salt, yes, that 20 moles will get dissolved and will get turned into solution, but at the same time the solution will also give us back 20 moles. So the amount of solute that is getting dissolved is equals to the amount of solute that we get back from the solution. So as I hope that you have understood what is happening at the saturated point and why the saturated solution cannot accept more amount of solute in it. It can, I hope you have understood, guys. I am not going to confuse you all more. If you are not clear, then please rewind the video 2 minutes, and I think that you will get obviously clear with that. So guys, now after understanding what is a saturated solution, now let us move on to understand what is solubility. So solubility is a number or a value which tells us the maximum amount of solute dissolved in unit volume of saturated solution. Okay, now what is this unit volume? For example, suppose your volume of saturated solution is in liters. So unit volume will be equals to 1 liter. Suppose your saturated solution is given in dm cube, then your unit volume will be 1 dm cube. As simple as that. So let us consider one small example over here which will help us to understand what is solubility. Okay, so let us consider that if 55 moles of solute is dissolved in 11 liters of saturated solution, find the solubility. Okay, so now what we know up till now, that in 11 liters of saturated solution 55 moles of solute is dissolved. Am I right? But in order to find out solubility, we want to know how much amount of solute is dissolved in unit volume. I repeat myself again. In order to find solubility, we want to know how much amount of solute is dissolved in unit volume. So guys, can I say here I want to find out how much amount of solute is dissolved in 1 liter. Now since I don't know this value, therefore I assume it to be S. Okay, I don't know that value, therefore I assume it to be S. Now how to find out the value of this S? By simply cross multiplication. Okay, so by doing cross multiplication I find out the value of S and it comes out to be 5. So guys, here the solubility will be 5 and the units will be moles per liter. Why moles per liter? Because if you observe here in 55 is nothing but moles and this 11 is nothing but liters. Okay, therefore moles per liter. So guys, I hope that solubility is clear for you all. It is very simple. Okay, now moving on, let's understand the different factors affecting solubility. So how you can change the solubility of a solution, okay, or of a solute, whatever you want. In books it is given as solute. Okay, now the first important factor is nothing but nature of solute and solvent. Obviously, solubility is going to depend on the chemical characteristics of a solute as well as the chemical characteristics of the solvent. Okay, so basically what we observe is that like dissolves like. Now what is the meaning of this? See, if the solute and solvent have similar characteristics, then both of them, so then in that case solute is going to get easily dissolved in solvent. I repeat myself again. See, if the solute and solvent have similar characteristics, then the solute is going to get easily dissolved in solvent. Okay, clear this? Now, the substances having similar intermolecular forces are likely to be soluble in each other, which means that if the intermolecular forces between in solute is almost similarly equal to the intermolecular forces in solvent, then the solute is going to get dissolved in solvent easily. Okay, so if they have similar intermolecular forces, they are likely to get soluble in each other. Okay, now another point that we generally observe is that the polar solutes dissolved in polar solvents. Now what is the meaning of this? See, if your solute and solvent, both of them are polar molecules. Now if you do not know what are polar molecules, then I have already uploaded a separate video on this. You can find the link in the description box below, or you can simply click on this I button which is present on the right top corner of your screen. Okay, so if both of them, solute and solvent, are polar compounds, or if they are polar molecules, or if they exhibit polar character within themselves, then solute is going to get easily dissolved in solvent. In general cases, polar solutes dissolve in polar solvents. And the reason behind this is that because the intermolecular interactions, or the interactions between a solute molecule and a solute molecule, and the intermolecular interactions between a solute molecule and a solvent molecule, and the interactions between a solvent molecule and a solvent molecule, all have similar magnitudes. So since all of them have similar magnitudes, therefore the solute is going to get easily dissolved in solvent. Okay, for example, let's understand this with the help of the example. So let us consider that NaCl dissolves in H2O. So when NaCl dissolves in H2O, what happens is that, see, solute-solute interaction, which means that here, as you can see, there is an interaction between a Na plus ion and the Cl minus ion of a solute, and there is an interaction between a solute, that is nothing but NaCl, and the solvent, that is nothing but H2O. And also there is an interaction between a solvent molecule, that is nothing but H2O, and another solid molecule, that is nothing but H2O. And the magnitude of all these three interactions will be similar. And since the magnitude is similar, therefore it is going to get easily dissolved. Clear with this? And we observe one more thing, guys, that non-organic compounds like cholesterol dissolve in non-polar solvents such as benzene. Okay, so this is the general thing that we observe. And sugar dissolves in water. Now this is the important point. So when sugar dissolves in water, because of intermolecular hydrogen bonding, so even the intermolecular hydrogen bonding is responsible for dissolving a solute in solvent. Clear with this? Now, This factor was very boring, I know that. But let's move on to the second factor, which is quite interesting. That is nothing but the effect of temperature. Okay, now the effect of temperature depends on two factors: whether your dissolution is endothermic process or whether your dissolution is an exothermic process. So first of all, let us understand the effect of temperature if the process of dissolution is an endothermic process. Okay, so for endothermic process, let us consider a saturated solution, and we all know that in a saturated solution there is a dynamic equilibrium that is being established. Okay, and since it is an endothermic process, dissolution is endothermic over here, therefore the heat, it will be absorbed by the reactant, that is nothing but solute dissolving with solvent. So when solute dissolves in solvent, it is going to absorb heat. Okay, therefore for endothermic process. Now, since this is a reversible reaction over here, therefore it is going to have a forward reaction, and the forward reaction in this case is simple: solute plus solvent plus heat gives us solution, and the backward reaction over here is nothing but solution gives us solute plus solvent plus heat, as simple as that. Now if we increase the temperature, now guys, if we increase the temperature, then guys, can I say that we are going to supply heat? By increasing the temperature, we are going to supply heat. Now focus on this forward reaction and the backward reaction. Which of them requires heat to get completed? Obviously the forward reaction requires heat to get completed, and if you supply heat, then it is going to dominate. So the forward reaction is going to dominate in this case. So guys, can I say that the forward reaction will be favored, and this forward reaction is nothing but a dissolution process where the solute dissolves with solvent and gives us solution. Okay, therefore if the dissolution process is favored, then obviously guys, the solubility will also increase. So I hope you have understood this point. Here the dissolution process is being favored, and therefore obviously solubility will also increase because more amount of solute will get dissolved in solvent. But in another case, suppose if we decrease the temperature. Now if we decrease the temperature, then the another reaction, that is nothing but the backward reaction, will be favored. It is nothing but reverse reaction I have written over here, or you can even backward reaction is the correct word. It's my bad. Here it must come backward reaction. Okay. Okay, so the backward reaction will be favored over here, and since the backward reaction is nothing but the crystallization reaction we have seen just now, in which we get back the solute, therefore obviously the dissolution is going to decrease, and hence the solubility will also decrease. Clear with this? Okay, now we have understood what is going to happen for an endothermic process. Now let us understand for an exothermic process. So while considering an saturated solution for an exothermic process, this is the dynamic equilibrium that we achieve. And since it is an exothermic process, which means that dissolution is exothermic, therefore we are going to get heat after a solution is being formed. Okay, clear with this? Now again, here we are having a forward reaction, which is nothing but solute plus solvent gives a solution and heat, and we are having a backward reaction where a solute plus solution plus heat gives us solute and solvent. Now here guys, if we increase the temperature, then we are supplying heat to the process. And which reaction requires heat? Obviously the backward reaction requires heat. Therefore, here the backward reaction will be favored. And as the backward reaction will be favored, backward reaction gives back solute. Therefore, there will be less dissolution. And as there is less dissolution, therefore the solubility will also decrease. So here if we decrease the temperature, then what is going to happen is that obviously the forward reaction is going to get favored, and the forward reaction is nothing but a dissolution reaction and dissolution process, my bad. And therefore obviously in this case the solubility will increase. Clear with this? Now moving on further, let me tell you all that this trend that we observe, that is nothing but for an exothermic process or for an endothermic process, is for general most of the reactions, but there are certain exceptions that we need to keep in mind. For example, a dissolution of CaCl2 in H2O is exothermic process, whereas a dissolution of NH4NO3 in H2O is an endothermic process. So we expect that if we increase the temperature, then the dissolution of NH4NO3 will increase and the dissolution of CaCl2 in H2O will decrease. But in this case, solubility of both increases. So you need to keep in mind the exceptions as well. Okay, the concept that we have seen is for most of the reactions, but here there are many exceptions as well. Now moving on to the last factor, that is nothing but the effect of pressure. Now obviously pressure has no effect on the solubilities of solids and liquids. Why? Because solids and liquids are incompressible. So even if you apply pressure to it, they are not going to get compressed easily. But the pressure greatly affects the solubility of gases in liquid. Okay, your gas, the pressure is going to affect the solubility of gas in liquid. Okay, so when gas is your solute and when liquid is your solvent, pressure is going to play a great role over here. And therefore Henry gave us a law which is known as the Henry's law, which tells us that the solubility of gas in liquid is directly proportional to pressure of the gas over the solution. So let us convert this into a mathematical expression. Therefore solubility of gas, let's assume the solubility of a gas to be S, and is in liquid is directly proportional, and we represent directly proportional by a alpha sign. Therefore I have written an alpha sign over here to the pressure of the gas over the solution. Therefore I have written P, which signifies pressure in this case. Now if I want to remove this direct proportionality sign and if I want to replace it with the equal to sign, I obviously have to add a constant over here. So now can I write this equation as S is equals to K, which is nothing but constant, into P. And guys, here this K is called as Henry's law constant. Okay, Henry law constant. And here the units of pressure will be in bar. Bar is the unit of pressure. Now moving on guys, I want to find out the units of this K, that is nothing but Henry's constant. Therefore what I do is that I write this formula in another way, that is nothing but K is equals to S upon P. Am I right guys? I have just shifted this P to the left hand side, therefore it is going to go into the denominator. Therefore I write it as K is equals to S upon P. And now the units of K will obviously be in numerator, the solubility is present in moles per liter, and in the denominator the pressure is in bar. Okay, therefore I write the units as mole liter inverse. Why liter inverse? Because liter is also in denominator. Okay, as you can see over here, and bar inverse. So when I take them in the denominator, they are going to have a -1 index over there. So this is all. And again for pressure there are certain exceptions for gases like NH3 and CO2, which when added to the solvent like water, they react with water, and as they react with water, therefore they have higher solubilities than expected according to the Henry's law. So guys, I hope that you have liked this video, and if you like this video, then please do not forget to subscribe to our channel and go check out my channel where I uploaded physics and chemistry videos. They might be helpful for you. And guys, thank you for watching this video.